Today we are doing lesson 9, determining perimeter and area of polygons on the coordinate plane. Jazit has made a scale drawing of a vegetable garden she plans to make in her backyard. She needs to determine the perimeter and area to know how much fencing and dirt to buy. Determine both the perimeter and the area. Okay, so the first thing we want to do is we want to find the lengths of all of our sides. So A to B would be 4. B to C would be 1, 2, 3, 4, 5, 6, 7. C to D is 1, 2, 3, 4. D to E is 1, 2, 3, 4, 5, 6. E to F is 1, 2, 3, 4, 5, 6, 7, 8. And F to A, I can add 6 plus 7 without having to count all of that and know that that would be 13. So we need to find her perimeter. So to find perimeter, we would add all the sides. So I would have 13 plus 8 plus 6 plus 4 plus 7 plus 4. Okay, so I like to add things that I find easy. So that would be that one. And then 13 plus 8 would probably be the hardest one, would be 21. 21 plus 10 is 31, plus 11 would be 42. So our perimeter is going to be 42. And they didn't tell us what we're measuring in, so we're just going to say U for units. So all of these would have little U's on them, because she could be measuring in meters or feet or yards, we don't know. Okay, so now the area. I'm going to change colors for this. And we're going to cut this up. So I'm going to draw a straight line down. I'm going to have the area of 1 and I have the area of 2. So AB would be our base. So the area of 1 would be 4 units times the area of the height would be 13 units. So 4 times 3 is 12. So we would have a 2, and 4 times 1 is 4 plus 1 is 52. So it'd be 52 units squared. The area of the second one, so that'd be 4 units times 6 units. So 4 units times 6 units. Area of the second one equals 24 units squared. Okay, so I have my two separate. Now I can add them together. So 52 units squared plus 24 units squared. Our label is going to stay units squared. 4 plus 2 is 6. 5 plus 2 is 7. So the area of the whole thing is 76 units squared. And then our perimeter is 42 units. Okay, example 2. Calculate the area of the polygon using 2 different methods. Write 2 expressions to represent the 2 methods and compare the structure of the expressions. Okay, so I'm going to use highlighter. I'm going to make it a little bit smaller. So the first thing I would do when I do this is I would cut it. I would cut it up like this. And then I have 1, 2, 3. I have 3 shapes. And I would find those 3 shapes. So I have the area of 1. And our base here would be 1, 2, 3, 4, 5, 6. So our base is 6 units times our height, which would be 1, 2 units divided by 2. So 6 times 2 is 12. 12 divided by 2 is 6. So it'd be 6 units squared. And the area of number 2, we would have 1, 2, 3, 4. And then our height would be 6. So it would be 4 units times 6 units. That'd be 24 units squared. Then our next one, the area of 3. So that gives us has the same base and the same height as our first one. So I'm just going to say that the area of 3 equals the area of 1. And we know that to be 6 units squared. So then I would add 6 units squared plus 24 units squared plus 6 units squared. And that's equal to, well, 6 plus 24 is 30. 30 plus 6 is 36. So 36 units squared would be our area. Okay, I'm going to make a little note here so that way we know for later. I'm going to kind of draw a really rough sketch, and I'm going to show how I cut it. So that way we know. Because now I'm going to erase this. Okay, so take a look at that. This is saying 2 methods, but I want to show you guys 3 methods. Because this one method is not a method that I would normally think of. So I want to make sure you guys see it. So instead of doing a triangle on each end, we do all triangles. So this would be 1, 2, 3, 4. And number 1 has a base of 1, 2, 3, 4, and a height. So the height would be right here, which is 1, 2, 3. So area 1, 4 units times 3 units divided by 2. 4 times 3 is 12. So it would be 12 units squared divided by 2 is 6 units squared. Okay, the area of 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So we have a base of 8 and a height of 3. So 8 units times 3 units divided by 2. So this would be 8 times 3 is 24, divided by 2 is 12. So it would be 12 units squared. The area of 3 also has a base of 8 and a height of 1, 2, 3. So that would be the same as area of 2. So I'm going to say, oops, I don't want to do that. I want to do area 3 equals area 2, which is 12 units squared. And now we have area 4, which is 1, 2, 3, 4, and our height is 1, 2, 3. So that's also the same as area 1. So area 4 equals area 1, which is 6 units squared. Okay, now we need to add these. So 6 units squared plus 6 units squared plus 12 units squared plus 12 units squared. So 6 plus 6 is 12. That would give me 3 12s, which would be 36 units squared. Is that the same thing we got up there? Yes. So I'm going to draw another little quick picture so we know how we did that one. And I'm going to erase again, because there are so many different ways we can do this, guys. So this one is one that I like. we make a box around it. So what we're going to do is we're going to find the area of the whole box, and then we're going to find these little pieces, and we're going to take those little pieces off. So our whole box is 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6. So the area of the box is 8 units by 6 units, which is 48 units squared. Now, the area of the base of 1 is 1, 2 by 1, 2, 3. Let's see. Let's look at all of these really quick. Is 2 the same way? 1, 2, 1, 2, 3. Yep. What about 4? 1, 2, 1, 2, 3. Yep. 1, 2, 1, 2, 3. So all of them, area 1 equals area 2 equals area 3 equals area 4. And all of those are 2 units times 3 units divided by 2, which would give us 3 units squared. And there are 4 of those, so we times it by 4, and that would give us 12 units squared. So then we would take 48 units squared minus 12 units squared. So our label stays units squared. 8 minus 2 is 6. 4 minus 1 is 3. And we once again got 36 units squared. So this time, there. So there's lots of different ways you can cut them up. As long as you have lines that you can count as your base and height, it'll be right. So you have these different shapes here. This one, you could cut like this and make work. Or you could go around like this. Same with this one. This one's a lot like the one we just did. Except for now, we have a trapezoid here. So you could cut like this, or if you only want to make one cut, go like this. You could also go around the outside there too. Okay, so there's lots of options. These ones, I would just cut those ones up when you have nice rectangulars. And then this one is pretty wild. It's a lot crazier than the other ones we looked at. But I think you guys can handle all of these. So